Hello there. This is team number 27. The title of our team is Personalized Healthcare Management System, and myself, Aryan Sachan. And first of all, I will give the introduction of our project. This this personalized healthcare management system is a digital health platform developed to offer a streamlined, intelligent, and patient-centric experience for individuals seeking proactive healthcare solutions. As health as healthcare becomes increasingly digitized, the need for personalized health guidance grows. This system addresses that need by utilizing machine learning algorithms and user input to create customized health recommendations, integrate appointment management, and track the vital statistics. Through an accessible interface, it serves patients managing chronic illness, fitness conscious individuals, and those looking for basic wellness advice. The objective of this project is to build a responsive digital interface accessible via web and mobile, generate health suggestions tailored to individual symptoms, lifestyle habits, and medical histories, offer an intuitive symptom checker to encourage self assessment, integrate appointment tracking and reminders, monitor user health data trends, and notify deviations from healthy ranges, ensure privacy, security, and scalability. The problem statement is in modern healthcare systems, patients often encounter challenges in timely consultation, access to health records, and tailored advice. Routine checkups may be delayed due to availability issues or patient negligence, worsening health outcomes. This system seeks to reduce dependency on manual healthcare management and empower users through automated intelligent features. The module details include React and UseState. React was used for developing the interface UI, leveraging its components based design to create reusable and efficient blocks for appointment, insights, and vital dashboards. UseState allows the application to handle dynamic data such as user input field, real-time health values, or toggling screens between the states. Browser router and link React Router DOM. Routing was achieved using browser router, ensuring seamless transitions across the pages such as login, dashboard, appointments, and health tips. Link was used to prevent full page reloads, thus maintaining the app's single page application performance. Use Navigate. Once a user performs a critical action, for example, books an appointment, Use Navigate programmatically redirects them to the success page or dashboard. This ensures fluid workflow transitions. React Slick Slider, used for visually appealing horizontal scroll ideas for health tips, motivational quotes, and recent test summaries. The slider autoplay, the responsive layout enhance the user engagement. Paper prototypes. Early prototypes included hand-drawn sketches for future layout, wireframes made in Figma tested for usability, variants showing different approaches to the vitals, entry panel, appointment interface, and AI health suggestions. Each module was refined through iterative peer reviews, culminating in a high fidelity prototype. The design evolution includes initial concepts. First of all, we have static HTML pages, no real-time updates, and manual data entry without visual aids. Second one is intermediate version, React integration. API mockups for symptom checker, added data persistence through temporary JSON storage. Third one is final design, fully dynamic SPA with intelligent routing, real-time input validation, fully responsive layout optimized for mobile. Fourth one is design improvements made. Simplified forms with inline guidance, added charts and graphs for vitals. CTA buttons made more accessible, larger and color coded. Dark and light theme toggle for visual comfort. Design changes rational. Users prefer clear and guided interactions. Accessibility tested for colorblind users also. Responsive testing conducted using Chrome DevTools for different breakpoints. User-centered design elements. Storyboarding. Storyboards provided a visual scenario of user flow. Key frames included. First one is Rahul waking up and checking glucose level, receiving an AI recommended breakfast based on readings, scheduling a follow-up appointment through a mobile notification. This is the sample design of UI which you are currently seeing in my PPT. Earlier, there were all these handwritten sketches. This is a sample design of UI, where first of all uh, first of all you can access the schedule and appointment section. After sign up, you can access the AI healthcare management system also, where you can enter your symptoms and the AI will guide you what kind of uh, medications you can take. We have general checkup, specialized care, and emergency services. This is the login page where you have to type your full name, email ID, and password for sign up. After sign up, you will be redirected to this page where your upcoming appointments and recent health metrics will be displayed. In the symptom checker section, you have to type your symptoms here, and based on the symptoms, personalized health tips will be available for you. For example, in this section, I have typed I am feeling low blood pressure. You can see that the initial personalized health tips were something different as compared to the other health tips because it is generated through AI based on the symptoms which I have entered.
So now I am going to explain the user scenario for this project, that is personalized healthcare management system. So now we will take the example of one person. His name is Rahul Mehta. So he is 35 years old and he is a diabetic patient. So he is a software developer. So he is very busy in his life. So that's why he wants some interface or something app so that he can maintain the whether he is having a diabetic or not. So he is having a type 2 disease, which he had 3 years ago. So he finds it hard to maintain consistent blood glucose levels due to irregular meals and stress. Rahul uses the app every morning to log his fasting glucose level using a Bluetooth enabled glucometer. So it's also very cheap, so he can purchase it. The app syncs the data instantly and generate personalized breakfast recommendations. So based on the report, it will generate which breakfast he had to take per week, per day, in a week. So like that. And next thing is that the example of some other person, namely Neha Sharma. She is the working mom of age 28. So she is a marketing executive and a mother of a 6-year-old child who suffers from asthma. So his child is very young, so it's very difficult for him. So she manages her busy schedule while ensuring her son's medication and symptoms are closely monitored. So the app allows Neha to log her son's asthma triggers, symptoms, and meditation adherence daily. So based on the input like pollen levels and past episodes, the app alerts her to the potential triggers in advance. So she received reminders for inhaler doses and doctor visits. So based on the report, she visits the doctor. So next example, another use case is of Manoj Patel. He is 65 years old and he's a retired person. So he's a retired school professor who lives alone and has managing hypertension for over a decade. With limited exposure to technology, he uses the app for basic monitoring of his blood pressure and heart rate. Every morning, he logs his visits using a simple interface with large buttons and voice guidance. He needs large button because he is eight, so he needs that based on the person's age. So the app provides daily wellness tips sodium reduced diets or such as sodium reduced diets or now every week a report is auto-generated and shared with his family doctor who provides feedback through integrated video calls. So the personas were developed using user real-world interviews and surveys conducted by us. So each persona included demographic, behavioral, medical, and technological literary information. So insights from persona inform button sizes, content layout, text complexity, and device occupation. So let us take the example of this person, namely Rahul Mehta. So he is 35 years old and occupation is he is IT professional. So his health status is he is diagnosed with type 2 diabetes, and the pain points are like he struggles with tracking glucose levels consistently, needs personalized health advice without frequent doctor visits, prefers mobile friendly access to health insights so that he can check the report anytime, anywhere. Then the goals and motivations are that he maintain stable glucose levels, get AI driven recommendations for diet and exercise, assess quick consultations when necessary. Now, next is the we have draw we have given the storyboard of the Rahul Mehta. First of all, he patient has booked the appointment, so he log into the dashboard and selects the doctor, and then do the appointment scheduling, and then the confirmation he gets through notification or something. And next is the doctor. He visits the doctor and he reviews the patient history frame. So the doctor first of all assess the system, view the patient history, review health data, and then he consult in and provides him with the tips and all. And next is the patients after consulting the doctor, patient check for the AI health insights. So first he logins and check all the health metrics entrance, and the system provides us with the recommendation that he needs to follow. So now the thing is, what are the UI design guidelines that are followed? So the first of all is the visibility of system status. Next is the match with the real world conventions. And next is the user freedom, error prevention, recognition and recall. Next is flexibility and efficiency. Next is types, typography and layout. So next is the design evaluation techniques. So heuristic evaluation. So conducted by Jacob Nielsen, 10 usability heuristic evaluator tested for visibility of system status, match between system and real world, user control and freedom. Consistency, error prevention, recognition and recall, flexibility and efficiency, aesthetic design, error recovery, and help and documentation availability. So observations were recorded and each heuristic valuation were categorized by severity. So think aloud protocol. So 10 users from diverse democracies interacted with the system while speaking their own thoughts loudly, and this revealed confusion points, emotional response, and overlooked features. So sessions were recorded and analyzed for future issues. So next is the user survey. So post-task surveys used 5 points Likert scale to measure satisfaction, ease of use, clarity of features, and likelihood of recommending the app. So open-ended feedback captured user option beyond structural questions. So the key findings from these all are positive insights. So user appreciated the personalization of health tips, fast vital loggings and immediate visual feedback were praised. Most users found the dashboard intuitive after initial use. The few areas which we have to look in the future are certain icons, that is heart symbol for vitals, were unclear to some users. So they were mostly the aged person or someone. So for that they find the unclear. So lack of a guided tool led to a confusion during the first session. So no novice or the beginner find it difficult to read the manuals. So some medical team were unfamiliar to lay users. So the modifications are visual aid enhancement. So help icons added to on every major panel, linking to short toolkits or model explanation so that the user can read out and then clarify their doubts. So glossary section integrated into the menu for users unfamiliar with meeting terminology. Onboarding improvements. Step-by-step onboarding tutorial introduced. Step-by-step onboarding tutorial introduced upon first login. Flow diagrams guide user from symptom entry to results interpretation. Now, terminology adjustments. Formal medical terms were replaced with user-friendly language where appropriate, so that any beginner or some aged persons can easily recognize those terms, what the meanings are. Added toggle section for basic versus desired via the reports. So the success metrics for this are task completion rate. Improve from 62% to 92% after enhancement, measured by successful completion of key tasks. Now error rate decreased to below 5% in form of submission and queue management modules. So errors were often decreased to below a submission queue and management modules. So now the user satisfaction score increased from 3.6 to 4.5 out of 5 after refinement. So after changing the UI design, the user satisfaction score increased. 90% of the user reported they would recommend the app. So retention and return visits. So simulated user sessions showed a 40% increase in repeat engagement over a 7 day span. Now we will see how AR VR considerations will be helpful in this kind of UI mod design. So AR integration concept, health data visualized in real time through smart glasses, glucose trend overlaid or breakfast table, augmented medicine self showing next dose time and interaction warnings. So VR integration concepts include immerse stress relief programs, breathing meditation, fitness training with posture correction, virtual doctor office simulation for remote consulting. Design feature for AR VRR emphasizes on minimal interface clutter, haptic and audio feedback for immersive realization, 3D avatars representing health status and advice. So the user benefits are elderly and physically impaired user benefit from VR guided workouts and youth engagement via gamified health experience. So the tentative modules used were React, use state from React, browser router from React Router DOM, link from React Router DOM, slider from React Slick, use navigate from React Router DOM, and router routes route link from browse router.
Hello, my name is Piyush. From here, I'm going to explain HCL principle applied. Keystroke level model, KLM. Every action mapped to click and input. Example, logging heart rate. Then you have to click vitals, select heart icon, type rate and submit. GOMS, goal operator method selection rules. Example, book specialist consultation. Goal, schedule visit. Operator, click, select, confirm. Method, from dashboard, click appointment, choose doctor, confirm. Rules, use saved doctor if consulted before. Fitts law, increase size of CTAs, join queue, save vitals. CTAs position a thumb reachable zone for one-handed use, target size greater than 10 mm on mobile screen. Impact on UX, reduce time on task, more intuitive user behavior observed, increase accuracy in form submission. Now I'm going to explain heuristic evaluation. Visibility of system status. Evaluation. The system provides a visible header with the title, healthcare management, and link to the main section. Um, the join the appointment queue section is well defined, but the system lacks explicit real-time feedback. Improvement. Adding a dynamic loading or confirmation message when the user joined the queue would improve feedback. Match between system and the real world. Evaluation. The interface use clear real world terminology such as general consultation, specialist consultation, and emergency care to describe appointments. The fee structure is also intuitive. Improvement. Ensure that the appointment types and fees match real world expectation and add more context if needed. Third point, user control and freedom. Evaluation. The user can select and click on button to join queue. However, once the queue is joined, there is no option to cancel or change the selection. consistency and standard evaluation. The design maintain consistency in the layout with uniform button, appointment box design, and font choice throughout the page. Improvement: ensure the button style and header are consistent across the entire website. Error prevention evaluation: the interface does not present many opportunities for error as user can only choose from predefined option. Improvement: prevent error by providing confirmation dialog or message when a user attempt to join the queue to ensure it. Intention: recognition rather than recall. Evaluation: user can see available appointment option with all necessary information without needing to recall or input anything. Improvement: consider adding tool tips or help section to aid users unfamiliar with medical terminology or process. Flexibility and efficiency of use. Evaluation: the system is somewhat rigid since user can only select appointment types without customizing. However, it is easy to navigate and no easy to navigate, aesthetic and minimal design. Evaluation: design is clean and the color scheme is visible, appealing the layout in minimal, focusing on key information, appointment type, and join queue button. Improvement: the join queue button could stand out more visible to make them more noticeable. Help user recognize, diagnose, and recover from error. Evaluation: since there are no form or complex process, error are minimal. However, once the user join the queue, there is no way to identify error or change. Improvement: implement a system that show confirmation when the user join the queue. Join the queue for specialized consultation, help, and documentation. Evaluation: the system is simple enough that it does not require intensive documentation. However, it might benefit from a brief help or FAQ section explaining how the queue system works. Improvement: add a tooltip or help icon next to key feature such as queue or appointment type for users who need assistance. Here are the references. The first reference we have taken from Hond CM, Genio, KP Swen, CR Kathleen BB, Country Health Ranking. These are the references from which we have taken. And here I'm going to end the presentation. Thank you.